Today I will show you on how to solve the physics in electromagnetic wave into energy and its frequency. First, let's have first the constant. So we have this, the constant, units and equations. Let's copy this and put in our text. Word, okay. Okay, so now we already have this. Let's have the red pen. Tap, cock. And next should have the problem first. No, let's discuss first what are those things. So constant speed of light, 3 times centimeter per second. Then Planck's constant, 6.63 negative 34 joule seconds. Electron volt, in 1 electron volt there is 1.6 times 10 to the negative 19 joules. In 1 meter it is 1 times 10 to the power of 9 nanometer. So let's first convert, or you did need to convert anywhere the speed of light into nanometer. So you have to do is just to multiply these numbers and to get the product of speed of light in constant in nanometer. Why are we using nanometer? Because in lambda they are using a unit of nanometer, like this, nanometer. Okay, so first let's have a problem. So we have this. The problem is compute the energy range. Okay, let's copy paste this problem. And now let's have some text right here and paste the problem. Now we have the problem. This is the problem. So compute the energy range. Compute the energy carried by the AM wave, electromagnetic waves, to electron volt. So we have the equations. First equation, we have the equation for energy. Equation for energy in electromagnetic wave. But after solving that, we convert that into electron volt unit. So in electron volt unit, again we have the constant. In 1 electron volt, we have 1.6 times 10 to the negative 19 joules. So first, we need first to analyze the question. The first is they ask about the energy. And how to solve that? We're going to use this first equation, which is energy. Let's use another black pen. So energy is equals to frequency times the Planck's constant. Okay, so we have that. Sorry for the penmanship. Okay, so now we have a given frequency, a gamma radiations, which is 2 times 10 to the power of 23 hertz. So energy is equals to, we have the frequency, 2 times 2 times 10 to the power of 23 hertz. and Planck constant. So we have the Planck constant, which is the Planck constant. So 6.63 times 10 to the power of negative 34 joules seconds. So close parenthesis, that means it is asking about the product. Since it can cancel out some units, we have the seconds, and hertz is the number of vibration seconds. So hertz cancelled out. And we are remaining about the joules, or a unit of energy. So on how to solve that, since we have a huge number, how to solve that? We're going to use a scientific calculator. In my case, I am using a simple calculator. Okay, this is the calculator. And now let's try to solve this. So we have 2 times 10 to the power of 23. So in my calculator, 2 exponent times 10 to the power of 23 times, get the product of the Planck's constant, 6.63 times 10 to the power of negative 34 negative sign. Okay, so we have this. So let's review. 2 times 10 to the power of 23. So this is 2 times 10 to the power of 23 hertz. Okay, we have that. 2 times 10 to the power of 23 hertz. The times with the product of 6.63 times 10 to the negative 34. And we have this result. Is equals to 1.33. You can convert that. 1.33 equals to 1.33 times 10 to the power of negative 10. What's the unit? Unit is joules. So we already solved for the energy only. Energy in this frequency. But next is going to convert that energy into electron volt. So how to do that? Now, since we have the energy equation, next is let's convert this. We have the conversion factor. In 1 electron volt, this is 1.6 times 10 to the negative 19 joules. So how? Okay, so let's rewrite this. Energy is equals to 1.33. Am I correct? Okay, yes. 1.33 times 10 to the negative 10 joules. Okay. Convert this. Let's have the open close parenthesis. Okay. So in 1 electron volt, there is this one. So in 1 electron volt, there is 1 eV, there is 1.6 times 10 to the negative 19 joules. So in this, we should first cross let's have first the product. So we have equals to 1.33 times 10 to the negative 10 joules EV, because we have the EV. Divide by 1.6 times 10 to the negative 19 joules. So we can cancel out some units. We have cancelled out joules. So we have the remaining is electron volt. So now let's have first to divide. 1.33 times 10 to the negative, so 1.33 times 10 to the negative 10. Negative 10. Negative 10. Divide 1.6. 1.6 times 10 to the negative 19. Negative 19. And we have the result 8.31. So equals to 8.31 times 10 elect 8 times 10 to the power of 8 EV. So So 8.31 times 10 to the power of 8 electron volt. And now, let's convert that into this corresponding name, the symbols. Since times 8, so it belongs to mega. So we have this, oh shoot. Let's have 8.3125 or 831. 831 because times 8, so convert this 831 3125 83125, so 0.83125. So let's move the decimal place into 8. 1 2 3 4 5 6 7 8. You put some 0 0 0 0. 1 2 3 4 5 6 7 8 8. Since in 8 there's no 8, but it is under mega, it's not in giga. Giga it's in 9 factors, while mega is in 6 factors. So we can have this 3 6 belongs to mega. So we have 831 mega 831 mega electron volt for its energy. We have the final answer. So again, let's review. We have the constant, we have the equations, we have the units. Okay. Now the problem is to compute the energy. So In computing the energy, we just first determine what equation should be used. Since you're asking about the energy, so energy is equals to frequency times its the Planck's constant. So we have the frequency given 2 times 10 to the power of 23 hertz, and the Planck's constant, it's really given 6.63 times 10 to the power of negative 34 joule seconds. To solve that, just get the product, cancel out the units, so the remaining unit will be joules because we're asking about energy. It is the capacity to do work. And since the other question is convert that into electron volt unit. So to convert that, we have the result, the product of computing the energy in a specific frequency. So just only to divide the Planck's constant and cancel out the units, and we have this back. So cancel out joules, divide, and we have the result in energy electron volt. And next, convert that. Let's move into 8 decimal places to the right. And we have this. And let's determine if the prefix, if this mega or electron